Standard pitch theory categorizes musical structures based on subjective function, treating them as distinct, isolated objects to be memorized separately. When analyzing the whole tone scale, the augmented triad, and the tritone pair, conventional analysis isolates them into separate silos. The Fret 11 constitutional rule requires a different approach. By adhering strictly to geometric coordinates rather than musical labels, we find these are not separate systems. Mechanically extracting the pitch geometry proves that these three structures are actually observer-dependent readings of the exact same coordinate hull. Complexity in this system does not come from adding new coordinates. It emerges entirely from how we choose to read the matrix. This diagram shows the exact Fret 11 source string. It is a case-sensitive, 12-coordinate chromatic series, where enharmonic substitution is strictly prohibited to preserve precise coordinate identity. We apply the N4 operator by extracting every fourth coordinate from this sequence. This rigid mathematical extraction collapses the string into exactly 4 distinct groupings, known as the 4 augmented families. If we isolate the first family, little a, capital C, capital E, we can measure its internal geometry. The distance between each node is exactly 4. 4 plus 4 plus 4 equals the 12 coordinates of the full source. Because the structure is strictly N4 symmetrical, it contains 0 internal N6, or tritone, edges. This dispels the common assumption that an isolated augmented chord has a tritone built into it. If the tritone does not exist inside the individual augmented family, we have to locate how the augmented structure interfaces with the diminished tritone field. To find it, we apply the N6 operator to all 3 coordinates of the isolated family simultaneously. A maps directly to capital D, C maps to little g, and E maps to little b. Reordering these new coordinates alphabetically produces a new sequence, little b, capital D, little g. This specific sequence perfectly matches the membership of the 3rd registered augmented family. The tritone operates exclusively as an external bridge. It acts as a transfer mechanism, proving the 4 augmented families exist as 2 distinct N6 linked partner classes. Rather than viewing these as isolated triangles, we can extend all 4 augmented families chromatically until the original source repeats. This matrix shows the result, a complete 12-row by 3-column augmented chromatic lattice. Reading across any row yields the N4 augmented sequence. Reading down any column traces the N1 chromatic progression. The N6 tritone transfer appears here as a diagonal displacement. Tracing the map from A to D requires moving over 1 column, dropping down 2 chromatic rows, and wrapping at the column boundary. This abstract diagonal path must not be conflated with the physical over 1, up 1 fretboard motion common to the guitar. The abstract lattice maps pure mathematical coordinates. It has no physical tuning seams or fret geometry. Confusing this mathematical layout with a physical instrument projection breaks the operational logic of the system. We can now return to the original 2 partner families, ACE and BDG. Interleaving these 2 3-note groupings in chromatic order forms a single continuous 6-coordinate sequence. Measuring the distance between every adjacent node in this new arrangement yields a constant interval of N2. That uniform N2 spacing generates a complete whole tone family. Interleaving 2 N6 linked augmented families perfectly constructs one whole tone hull. The whole tone scale is the mathematical union of these augmented tritone pairs. This diagram shows a compression hull, a layout where a single set of coordinates simultaneously stores multiple independent structures. An observer reading adjacent nodes extracts the N2 whole tone sequence. Using the exact same coordinates, an observer reading every alternating node extracts the N4 augmented symmetry. Reading straight across the hull extracts the N6 tritone pairs. The entire matrix scales perfectly. 12 coordinates yield 2 whole tone hulls, which contain 4 augmented families, linked by 6 tritone bridges. No coordinates are added or removed during this process. The musical object you see depends entirely on the extraction rule you apply to the hull. Memorizing independent scales and chords fragments our understanding of pitch geometry. Instead, we find that whole tone, augmented, and tritone geometries are simply different observational states of a single, beautifully unified coordinate hull. Accurate structural analysis relies on exact mechanical extraction, bypassing subjective labels to reveal how the matrix is actually built.